Hi there, this is Dr. C. Sonia, Assistant Professor in Chemistry, SNS College of Technology. In this video, we are going to see about the energy resources, that is the nuclear fusion reaction. So in the previous video, we have seen about the nuclear fission reaction. So what is nuclear fusion reaction? It is a combination of the lighter nuclei into a heavier nucleus by liberation of large amount of energy. The lighter nucleus they combine together at a very extremely high temperature around 1 billion degrees centigrade, and these type of reaction because they are taking place at a very high temperature they are also called as the thermonuclear reaction to form the heavier nucleus along with the release of large amount of energy. So in this illustration, we'll see about the deuterium. They form the helium, two molecules with the emission of large amount of energy. So in the diagram, we can see that tritium and deuterium, they form the helium plus neutron plus the release of higher energy. Two deuterium molecules, two deuterium atoms, they form helium by releasing energy. So the red color, it denotes the proton and the yellow, the neutrons. So there are certain disadvantages. That is, this fusion cannot build a power plant. No material is available for building the power plant. In the nuclear fusion reaction, there are certain characteristics of this nuclear fusion reaction. That is, there is no limit on the nuclear fusion reaction. It occurs only when the distance between the two nuclei is lesser than 1 Fermi. So the distance between the two nuclei must be very close for the nuclear fusion reaction to take place. Sufficient amount of the kinetic energy is required for the fusion reaction. So energy in fusion is almost 4 times that of the energy in the fission reaction. Fusion is not possible with a heavier nuclei because electrostatic repulsion is very high in the when a heavier nuclear or a larger molecule is atom are to be fused together. So now we are going to see about the differences between the nuclear fission and the fusion. So first is the nuclear fission. It is the process of the breaking of the heavier nucleus into a smaller one by the release of large amount of energy. Nuclear fusion, it is the process of combination of the lighter nuclei to form a heavier one with the release of energy. Nuclear fission reaction, it emits radioactive waves. Nuclear fusion, it does not emit any kind of radioactive waves. And nuclear fission, it occurs at ordinary temperature. Nuclear fusion, it occurs at high temperature. That is, it should be greater than 10 to the power 6 Kelvin. And the nuclear fission reaction, the mass number and the atomic number of the new elements are lower than that of the parent nucleus. So they getting the parent nucleus, they're getting divided into the nuclei which has the lesser number of the mass number or the atomic number. In nuclear fusion reaction, the mass number and the atomic number of the product is higher than that of the starting elements. So because the lighter atom, they are fused together to give the heavier atoms. And it gives, in nuclear fission reaction, it gives rise to chain reaction. Nuclear fusion, it does not give rise to chain reaction. In nuclear fission, it emits neutrons. Nuclear fusion, it emits positron. The nuclear fission reaction, it can be controlled, and in the case of nuclear fusion reaction, it cannot be controlled. So these are the major differences between the nuclear fission and the fusion reactions.